Hello, testing. 1, 2, 3. How's the audio? So here I am. This is stream number 1, and I'm learning game dev. Learning game dev. As a web dev. So I am embarking on my journey to learn game development. I've been doing a bunch of research into game engines, and I want to build a little kind of action, kind of RPG game with the least amount of friction as possible. And I've landed on Godot. Godot or Godot, not quite sure how to pronounce it just yet. And in this stream, I'm gonna try and just work through the docs. This is me learning game dev as a web dev. Let's see how far I get. Okay, so this is the introduction to Godot. I'm gonna call it Godot, and I'm just gonna start reading. This article is here to help you figure out what Godot may be a good fit for you. We'll introduce some broad features of the engine to give you a feel for what you can achieve with it, and answer questions such as what I need to do to get started. Not an exhaustive overview. What is Godot? I have a general idea of what Godot is. I know that you can do 2D and 3D. This looks kind of cool. I would love to be able to do some Star Fox clone in the future. This is probably similar to what I want to build. I want like a 3D isometric ARPG game. That's what I want to do. That's where I want to get to. Yeah, this looks cool. I have got Godot installed, which I should probably get fired up. Here it is. I've got a little Godot testing project already. And yeah, I am aware I can use VS Code with Godot, yes. Yeah, I am coming into GD script completely cold. I did do a bit of Python. I am a TypeScript, JavaScript developer. That's what I do day to day. From what I've seen of GD script, it looks really neat and tidy. I haven't done too much low level C or C++ stuff. So you can write gameplays or high performance algorithms in C or C++. That's kind of cool. Nice. So what do I need to know to use Godot? Yeah, feature packed game engine. Thousands of features. There's a lot to learn. Totally aware of that. This is why I want to hyper focus on just very specific game mechanisms.
Hey.
Hello.
You look smart. What are you doing?
Streaming.
Recording. Oh, geez, I was looking into it.
Mm-hmm.
Oh, sorry.
That's okay.
You're going to edit me out?
No.
Oh.
I'm not entirely new to programming, and yeah. Learn to code with GD script. I don't need to learn to code from scratch. Let's skip this page. Overview of Godot's key concepts. Every game engine revolves around abstractions. I've actually read this already. You can a game tree. Oh, sorry, in Godot, a game is a tree of nodes. Yes, I understand that everything are nodes in Godot. Godot's nodes are grouped together in scenes. We can wire these nodes together and they communicate using signals. So I do a lot of React. So signals is a new primitive coming in web development. I wonder if it's inspired from it, but I imagine that you pass data down, signals go up, and actions happen. Hopefully it's the same kind of concept. I should probably check the stream's actually playing over here. Bear with me one sec. I am a noob to Twitch, as well as to everything else going on here. Okay, cool. I'm live on here. Nice. Neat. Okay, back to learning. Let's get some nice relaxing music going on as well. What should we get going? Let's get some focus music going on. Hopefully that's not too loud. Scenes. In Godot, you break your game down into usable scenes. A scene can be a character, a weapon, a menu, and user interface. A single house, an entire level, anything you think of. Godot scenes are flexible. They will fill the role of both prefabs and scenes in some other game engines. Don't know what prefab is. You can also nest scenes. For example, you can put your character in a level and drag and drop a scene as a child of it. Okay, so we got the game scene, we got the level scene, we have a player node, I'm guessing. This player has some hooks. Oh, wait, hold on, these are all nodes. Okay. Nodes. A scene is composed of one or more nodes. Nodes are your game's smallest building blocks and your venture's trees. Here's an example of characters and nodes. This player a player node is composed of a camera 2D, a sprite 2D, collision shape 2D. Okay? It's made of the character's body 2D, player, camera. Okay, that's what we just said. The node names in the 2D because it's a 2D scene, the 2D counterparts have names in the 3D. Be aware of spatial nodes that are now called node 3D, starting code 4. Notice how nodes and scenes look the same. When you have a tree of nodes as a scene, it then shows as a single node. Wait, hold on. Yeah, it does look very similar to the scene. Yeah. Okay. So when you save tree of nodes as a scene, it then shows as a single node with its internal structure hidden in the editor. Godot provides extensive library. I don't fully understand that yet, but it probably makes sense once I dive into it. Okay, so we have a node. This is another node. The scene tree. All of the game scenes come together in a scene tree, literally a tree of scenes. And as scenes are trees of nodes, the scene tree is also a tree of nodes. But it's easier to think of your game in terms of scenes as they can represent characters, weapons, doors. Okay. My understanding of this is that nodes are kind of like compartmentalized objects of logic. When you compose these nodes together, they become something more meaningful. A scene. A scene is a useful primitive that you create for your game. This is where I'm at. Hopefully that makes sense. Signals. Nodes emit signals when an event occurs. Okay, yeah. This feature allows you to make nodes communicate without hand writing them in code. It gives you a lot of flexibility. I mean, my head's already going directly to like JavaScript events, on-click events. It's got to be the same kind of thing here. Signals are Godot's versions of observer pattern. We have to observe the pattern. X state. Anyways, I'm not gonna digress. Let's just go. Okay. We can go down a rabbit hole here. So, yeah, buttons that make signals when pressed, fine. Other building signals you can tell when two objects collided. Okay, sirens. Nodes, scenes, the scene tree, and signals are four core concepts in Godot that you'll manipulate in time. Nodes are your smallest building blocks. Okay, yeah. I get it. Nodes, scenes. Okay, what else is there? Okay, first look at Godot's editor. This page will give you a brief overview of Godot's interface. Yep, the project manager, already seen this. Yeah, the asset manager looks neat. It sounds like there's a massive archive of assets I can use for free, which is neat. You can change the editor's language and drop down. Okay, whatever. Don't care about that. The Godot editor. Now this is what I wanna like. Let's. What am I doing? Okay, let's stick this over here. Let's stick this over here. Okay. Oh, thank you. Just realised my hair is totally messy. Got distracted. Okay, so where was I? First look at Godot's editor. When you first open a new project, let's look at its main areas. Okay. Yeah, this is what I got. So we've got the 3D view. Got 2D view. Yeah. By default, it features menus, main screen, blah blah blah. Okay, perspective. 3D looks kind of fun. Top view, bottom view. Top view. Right view. Rear view. Display lighting, interesting. Okay. I'm kind of scared about working in 3D, but I'm gonna cross that bridge when I get to it. Yep. Yep, toolbar changes depending on 2D and 3D, fine. The scene doc lists the active scenes nodes, okay. Here's my file system, here's my nodes. Okay. When you click one, it expands. The bottom panel. Oh yeah, that's this thing. Okay. Shader editor. Animation, debugger, output. The 4 main screens. There are 4 main screens. Buttons centered on the top of the 2D, 3D script asset lib. 2D, 3D script asset lib. Yeah. You use the 2D screen for all types of games. In addition to 2D games, 2D screens where you build your interfaces. Oh, that makes sense, yeah, because your interfaces are only going to be 2D. Yeah. Okay. In the 3D screen, you can work with meshes, lights, designs for 3D games. Okay. Notice the perspective button on the toolbar. Click on it, opens a list of options related to 3D view. Yeah. Okay. Yeah, I did see that. The screen. Yeah. Okay. Yeah. You see, I think the game that I want to build is gonna have a perspective sort of like this. You know, it's gonna be interesting to see if I'm gonna rely on 2D or 3D for that. Script scene. Yeah. Okay. That's gonna be fun. Finally, the asset lib is a library of free and open source add-ons. Yeah. Integrated class reference. Godot comes with a built-in class reference. You can search for information about class method property by pressing F1 or Option Space. Yeah. Okay. Clicking to search help, blah blah blah. Clicking while pressing function. Yeah, nice. Double click on item to open the corresponding page in the script main screen. Okay, fine. Okay, features. Godot is a feature-rich game engine. There's a lot to learn about it. Yeah. This page explains how you can use the online manual. Okay, making use of this manual. When you're reading, what you're reading out is the use manual. Thank you very much. It documents each of the game's concepts, available features when learning, so people start like browsing the corresponding section of this website. Okay, thank you. I know how it works. Okay, that's nice that we have a nice help built in. Yep. No, that is oh, that just taking okay. Okay, whatever. Class reference for classes. Ooh-wee, okay. Okay, this is fun. Class reference tells where the class exists in the inheritance hierarchy. Click. Top limits to class classes. Okay. Character body 2D. Summary of the class role and use cases. Explanation of the class properties, methods, signals, enums, constants, links to manual pages. Okay. Learn to think like a programmer. Teaching programming foundations. How to think like game developer is beyond the scope of Godot's documentation. If you're new to programming, we recommend 2 excellent courses. I've actually never done CS50 and it looks amazing. Maybe I should get around to it one day, but I'm a full-time developer. I think I know how to think like a programmer, but sometimes crippling imposter syndrome does kill me. I have read bits of this. It's actually a great book. Yes. Learning with the community. Yeah, the Godot community looks awesome. I can't wait to try and contribute some interesting things back if I can. Yeah, cool. Godot forum. Oh yeah, I definitely will be signing up to this. Add 2 numbers continuously. Top down 3. Oh, we got nice. 3D top down shooter. Yeah, this is. Oh my god, I actually want to build something like this. This is. It could be interesting. I'm gonna send this to my mate. Nice. Okay. There's gonna be a lot of cool shit to use here. Nice. Please don't take a picture of your phone. Come on, man. Really? Please do it in this. You don't need. You don't need. Just print screen. Come on. Right. Okay. It's stupid. I'm itching to code. Design philosophy. Okay. Let's try and absorb some of this in. Let's talk about Godot design. Every game engine is different and fits different needs. Not only do they offer a range of features, but the design of each engine is unique. This leads to different workflows and different ways to form your games and structures. This all stems from their respective design philosophies. The page here is to help you understand how Godot works, starting with some core pillars. It's not a list of available features, nor is it a game engine comparison. I think this is a really good page actually. I'm interested to understand about the way you're supposed to think when you're designing Godot games. I think this is like the mental models are important to build up from day one. So I'm going to try my best to absorb this. To know if any engine can be a good fit for your project, you need to try it out for yourself and understand its design limitations. Please watch Godot explain in 5 minutes.
In this video, you're going to learn what the Godot game engine is and what it can do for you.
Yeah, shall we watch that? An overview future game engine features. I kind of know-ish what it is, but I'm gonna finish reading this and then I'm gonna look at the video. Godot embraces object-oriented design at its core with its flexibility seen node hierarchy. It tries to stay away from strict programming features to offer an intuitive way to structure a game. I mean, object-oriented probably makes most sense in most games, right? I'd be interested to see how anyone else builds games any other way. But yeah, don't like object-oriented programming for web, but I think it makes a lot of sense here. It's like nested prefab. What is a prefab? Prefabricated homes. What are prefabs again? Prefabs in Unity are essentially templates in which you can create new objects or scenes. They're used to store game objects' properties. Okay, so like, is that prefabs are like nodes in Godot? Okay, that's what I'm getting. You can create a blinking light scene, a broken lantern scene that uses the blinking light, then create a city filled with broken lanterns. Change the blinking light color and all the broken lights will update instantly. On top of that, you can inherit from any scene. Cool. A Godot scene could be a weapon, a character, an item, a door, anything you like. It works like a class in pure code, except you're free to design it by using the editor, using only the code or mixing and matching the two. It's different from prefabs you'll find in several 3D engines. You can then inherit from and extend those scenes. You may create a magician that extends your character and modify the character. This is where object-oriented can just get really complicated. Like, this makes sense when you have a simplistic demo like this, but you can really overthink it. Like, do you have a human class that inherits from a character class, and do you have a mammal class that, like, you can definitely overdo it for sure, right? But yeah, you kind of have to be pragmatic, I think. Also note that Godot offers many different types of objects called nodes, each with specific purposes. Nodes are part of a tree. We talked about trees. Inherits from the parents up to node class. Although the engine does not feature nodes like collision, shapes, and parent physics bodies we use, most nodes work independently from one another. In other words, Godot's nodes do not work like components in some other game engines. I don't know how those game engines work, so that means nothing to me. Sprite 2D is a node 2D canvas item. A canvas item and a node. It has all the properties and features of its three parents. Okay, so Sprite 2D is a node 2D. Canvas item. A canvas item and a node all has properties of its parents. Okay, yeah. Godot tries to provide its own tools to answer most common needs. It has dedicated scripting workplace, an animation editor, a tile map editor, a shader editor, a debugger, profiler, ability to hot reload locally, oh yeah, and on remote devices, etc. The goal is to offer a full package to create games and continuous user experience. You can still work with the external programs as long as there's import plugin available in Godot, or you can create one like the tile map importer. What is this? Ooh. This is a plugin for Godot engine. What am I looking at? Plugin for Godot engine to import tile sets. Okay, that looks useful. Cool. Alright, okay, so it's extensible as a piece of software. Okay, we have plugins, basically. Okay. That is also partly why Godot offers its own programming language, GScript, along with C#. GScript is designed for the needs of game developers and game designers, and is tightly integrated in the game engine and editor. GScript lets you write code using indentation-based syntax via edit text types and offers static language, quality auto-completion. Yeah, baby! I love types, especially coming from TypeScript. This is going to be fun. It is also optimized for gameplay code with built-in types like vectors and colors. Note that with GD text extension, you can write high-performance code using compiled languages like C, C++, bro. Okay. Or Swift. Oh. Cool. I guess if you have very complicated algorithms, it might make sense to implement it using a lower level programming language. Very interesting. Okay. But for like, I guess, like in web development, you're just kind of gluing features together. And GDScript is probably the best. It's probably a very optimized language for doing, like, just bringing things together, composing things together. Yeah, okay, cool. Note that 3D Workspace doesn't feature as many tools as the 2D Workspace. You need external programs or add-ons to edit terrain. Okay, fine. So I'm guessing we need like Blender. Godot provides a complete API to extend this functionality using the code. The Godot editor is a Godot game. Oh yeah. That's clever. The Godot editor is a Godot game. Right. Yeah, this is a state machine. That's what it was. Lets you manage states and transitions visually. Nice. I've never worked with state machines before, but I feel like I'm finally gonna get a chance to learn why it's important in games. Flying, falling, yeah. Okay. Godot offers a fully open source code base on them. See, okay, anyone that can plug in proprietary, blah blah blah. Okay, community driven. Yes, I know it's community driven. I understand how important that is. The Godot editor runs on the game engine. That's so meta. Okay, it uses the engine's own UI system. It can hot reload code and scenes to test your projects. This means you can use the same code and scenes for your games or build plugins in the standard editor. This leads to a reliable and flexible UI system. It powers the editor itself with tool annotation. You can run any game code in the editor. RPG in a Box is a voxel RPG editor made with Godot 2. It uses Godot's UI tools for its node-based programming system for the rest of the interface. So you can use Godot's UI tools as part of the game. Wow, okay. Very meta. Okay. The editor is fully written in C++, statically compiled into binary. This means you can't import it as a typical project. That you have a project Godot file. Separate 2D and 3D images. Godot Editor offers a dedicated 2D and 3D rendering engines. As a result, the base unit for 2D scenes is pixels, even though the game engine is separate. You can render 2D in 3D, 3D in 2D, and overlay 2D sprites and interfaces over your 3D world. I need to send this to my friend because this is exactly what we were thinking about a future game we're going to try and develop. No, not prefabs. That's funny. No, not prefabs. Where was it? This is interesting. Okay. Step by step. The series built upon the introduction to Godot. The following are prepare you for your first 2D game, a step-by-step tutorial where you code a game from scratch. By the end of it, you have necessary foundations to explore features and explore more features in other sections. We include links to pages, blah blah blah. Oh yeah, we're finally gonna start coding. Here we go. Nodes and scenes. An overview of Godot's key subsets. We saw that. We saw this. Yep. So excited that we can start coding at last. All nodes have the following characteristics: name, editable properties. They receive callbacks to update every frame. You can extend them with new properties and functions. You can add them together as a node, as a child. Okay, cool. The last characteristic is put together. Nodes form a tree. Yep. Okay. They keep banging on about this concept. I get it. Since different nodes have different functions, combining them produces more complex behavior. As we saw before, you can build a playable character. The camera follows the character body 2D, node, sprite 2D, camera 2D, and collision shape 2D node. Scenes. When you organize nodes in trees, like character, we call this construct as scene. Yes, one saves the scenes, work like nodes, types in the editor, we can add them as a child of an existing node. In that case, the instance of the scene appears as a single node with its internals hidden. Yep, cool. Scenes allow you to structure a game's code however you want. You can compose nodes to create custom and complex node types, like a game character that runs and jumps, a life bar, a chest. You can interact with them more. Okay. Godot's editor essentially is a scene editor. It has plenty of tools for editing 2D and 3D scenes as well as user interface. A Godot project can contain many of these things as you need. The engine only requires one actual application's main scene. The engine only requires one Azure application's main scene. Okay, yeah. This is the scene Godot will first load when you and your player runs the game. Okay. On top of acting like nodes, scenes have the following characteristics. They always have one root node, like the player, for example. You can save them into your local file drive and load them later. You can create as many instances of a scene as you like. You can have 5, 10 characters in your game created from your character scene. Creating your first scene. Let's create our first scene with a single node. Here we go. We can create a new project. After opening the project, you should see an empty editor. Here we go. In an empty scene, the scene dock on the left shows several options to add nodes quickly. 2D scene adds a node 2D. 3D scene adds a node 3D. User interface adds control node. Oh, nice. So we have a dedicated user interface node. That's very handy. We're going to add a single label node to our scene. Oh my god, how exciting. Press the add child node, other node create root node. Here we go. Then we will create one node. What am I looking for? Label. There it is. It's a canvas item, control, label. Okay. Create. Ah, click the node label, select it and create button. Okay, cool. What am I doing? There it is. A lot happens when you add a scene first node. The scene changes 2D to up because the label is a 2D node. That makes sense. Okay, changing a node's properties. Okay, there's the node. Text. Hello, Godot. Okay, I did something. Cool, you can move it, running the scene. Did I just create my first game? What's going on? Oh my god. I'm running it. Why is it taking so long? Hey, debug. Hello, Godot. Wow. I did it. How do I get out? How do I escape this? Let me out. Let me out of here. Oh my god. Okay, cool. Well, that was very underwhelming. Label TSN. Where's that gone to? So with the levels back anyway, in the viewport, move it to the center of the view delimited by the rectangle. Center. Center. I want to save that. Is it saved? How do I save? Where is this interface? Where's the play button for this? Node history inspector. Okay. Right of the screen. Oh, it's over here. So we can just press play like that. No main has been defined, select current. Still on the top left there. Wonder why. Okay, fine. Whatever. Come on, plus dot. Cool. Yeah, I already did that. Pick a main scene. Create files. Cool. Editor saves the main scene as a project in your project directory. While you can edit the text file directly to change project, you can always use project settings to do that. So Godot project settings. There's a lot of stuff in there. Just gonna ignore all of that for now. We will discuss another key concept in the game together, creating instances. Creating instances. In the previous part, we saw that a scene is a collection of nodes organized in a tree structure. A single node has its root. You can split your project into any number of scenes. This feature helps you break down and organize your game's different components. You can create as many scenes as you like and save them as files with the TSCN extension, which stands for text scene. Okay, yeah. The label text scene from the previous episode, for example, we call those files packed scenes as a pack label. All those files are packed scenes as a pack information in the scene content. For ball post or rigid body 2D. So I'm kind of curious. So does that mean if I go to my projects, Godot testing? Oh, okay, so it's here. Surprisingly, not that much stuff in here. Mine's a bit crazy. Fine. Here's an example of a ball. It's composed of a rigid body 2D. Has its root named ball, which allows you to fall and bounce on balls. Okay. So what am I doing? text scene. I think this is what it starts with the game instruction and properties and important. You can modify each independently, such as change how they bounce, how they get out. Okay, let's use instancing in practice to see how it was in Godot. We invite you to download the bore sample project. Instancing task. So, do I close this down? Open up the Godot. Instancing. Okay. Okay. Every instance of the board scene starts with the same structure and properties as board text scene. However, you can modify each independently and change how they bounce, however they are. Okay, in practice. Okay, done that. In there. Important edit. Yeah. So the project contains two packed scenes. The main text scene. Containing wars, which the wars collide against. War 7. Okay, what's the wars? Okay. Let's add a ball as a child of the main node. Okay. Okay. Oh, okay. And then we're going to add a ball. There's a ball. Ball appears in the top left corner of the viewport. Okay. Alright, let's add it there. Look at that. Now you control my anyway. Now we want to create more balls. Just create another one. I think this is not the wrong level, right? Shouldn't this be leveling level? Loads of balls. Loads of balls. Okay. Okay, fine. Editing scenes and instances. There is more to instances, but this feature you can change the properties of one ball without affecting the others using the inspector. Okay, so let's take this ball. So can I just run that? Oh no, that runs the whole thing. Okay, that's the main scene. Okay, so inspector. Change the properties of one ball without affecting others using the inspector. Change the default properties of every ball by opening ball TSC. Upon saving, orders load. Okay. Changing a property on an instance always overrides from corresponding pattern scene. Let's try this. Open ball TS scene, text scene, and select the ball node. How do I open the ball text scene? Oh, okay, so it's this. Open scene. It's got to be this, right? That's the main one. That's vortex scene. Right, click on the physics material. Physics material. Stupid. Sprite 2D. Silk shape. That's the whole thing. Oh. It was that. Okay. More bouncy. Okay, so they're all bouncy. Okay, so now let's adjust an individual instance. Okay, so I'm going to put this back to 0. Okay, not bouncy. We're going to take 4, 6. Select on one of the instance balls nodes and in inspector set its gravity to 10. So that didn't really work. Okay. So I just 2004 6. Can I just edit that one? rigid body 2D. Is that where I went wrong? That's 10. Head back to the main scene. Clicking on the corresponding tab above the viewport. Yeah, did that. Select on one of the instance boards nodes. 4, 6, okay. You know what? We're just gonna do one of these. How does it add addable? Addable. Okay. 2 balls. Okay. So this is ball 2, yeah. That's ball 2. So this one I'm gonna set to 1. One's 1, that one's 10. Yeah, okay, we've got different gravity. Even if you modify the property in the original scene, the value overall will be certain in this. Okay. Rigid. So the ball. That sounds kind of dangerous, that you can kind of bypass the global kind of properties for that. Okay, so if we go on here and revert that back to 1. Like that. So what does that do? That's super dense now. Yeah. So that means I've overridden this instance of it has an overridden property. Fine, okay. This one's still default. It's gone up. Oh, what's happened? Yeah, it's gone up. Doing. Okay, fine. Okay, instancing makes sense. You can override instances. Okay. I know this requires a physical state. This is because it's a resource. Physics material. I don't know what the material is. Material which is connected. Okay, no, that makes sense. It needs to be made of Ball 2. resource unique for what instance? Right click on it and inspector. Make unique. I don't really understand what this is doing. But are we saying access as unique name? Make unique. I don't see make unique. Access as unique. Okay. I don't know what that's doing. Scene instances as a design language. Okay. Instances and scenes offer excellent design language, setting the scene apart, setting the engine apart from others out there with some Godot around this concept from the ground up. We recommend dismissing architectural patterns when making games with Godot. Such a model view controller. Instead, you can start by imagining elements placed for scene game and structuring code around them. Okay, very cool. For example, you could break down your shooting games like this: a stage, cool. Okay, you come up with a diagram like this for almost any type of game. Each rectangle represents an entity that's visible in the game from a player's perspective. Once you have a diagram, we recommend creating a scene for each element listed in it to develop your game. You use instancing either by code or directly in the editor to build your tree of scenes. Programmers tend to spend a lot of time designing abstract architectures and trying to fit components into it. Design based on scenes makes development faster and more straightforward, allowing you to focus on the game logic itself. Because most game components map directly into a scene, using a design based on scene instantiations means you need little architectural code, little other architectural code. Okay. So do I understand what's going on here? So a stage is composed of all of these things. Okay. There are obstacles. There's a HUD. You can access the market via the HUD. There are enemies. There's another enemy. Your playship owns weapons. Weapon is an instance of weapons. Enemy is an instance of missile. Okay. Once you have a diagram, we recommend creating a scene for each element. Creating a scene for each element listed in it to develop your game. You use instancing either by code. Yep, okay. Okay. That ready. Imagine we started by creating the room. I just realised this is so small. So sorry for the stream. My hair's going crazy. Imagine we started by creating the room. We could make a couple of different room scenes with unique arrangements of furniture. Later we can make a house scene that uses multiple room instances for the interior. We could create a citadel out of any instance houses, which will replace each of these will be a scene producing one or more sub-scenes. Later we can create scenes representing guards and adders. They will be indirectly added to the overall game mode. With Godot, it's easy to iterate on your game like this, as all you need to do is create and instantiate more scenes. With design to edit to be accessible to programmers, designers and artists alike, a typical team development can involve 2D or 3D artists, level designers, game designers, animators, all working on a Godot editor. Yeah, this is interesting. So each one of these things becomes a scene. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120 process of producing objects from blueprint has many handy uses. With scenes, it gives you the ability to divide your game into usable components, a tool structure to encapsulate complex systems, a language to think about your game's projects in a natural way. Okay, and that's really interesting. So we can think about our games as this diagram initially becomes a blueprint of pieces to actually implement. So I haven't actually done any coding yet. All I've done is mess around with the UI. So I'm going to actually do some coding now. Work in progress. It has not been updated for Godot 4.2, maybe outdated. But payable scripting languages, yeah, okay. Which language should I use? If you're beginning, we recommend starting with GD script. We use this language specifically for Godot, and these will get their vectors. I'm going to use GD script. It looks great. For C#, you will need an external code editor like VS Code. VS Code. Pros and cons. Object-oriented. Imperative. What's imperative? These statements that change a program's state. Terms often. Oh, okay. Yeah. Yeah. So you can mutate properties and it changes the state. Short files, blazing fast compilations and loading times. Tight editor integration. Code compilation node signals, more information seen in Snatch 2. Support multiple threads. No garbage collection. As this feature eventually gets in the way of games, the engine counts references and manages them for you. In cases by default, you can also control them if you need to. Great typing. Sweet. It looks like Python actually it doesn't work the same way in practice. It's inspired by multiple languages, including Squirrel, Godot, and Python. Okay. Why use Python all the way direct? Use Godot, use Python, then Lua. Both languages integrate to a lot of work and severe limitations. For example, threading support is a big challenge for Python. But I think a dedicated language doesn't take us more work and tailor it to game developers' needs. We're now working game for applications. Okay, fine. I'm not gonna do this. Oh, nope. Nope, not doing C#. This is very interesting. Whoa. I'm gonna be scared if we need to go this low level. We shall see. Coding first script. We'll code your first script to make Godot open time into circles, as we mentioned in the explosion. Here we go. So I'm gonna open up my project again. actually gonna do something. It's Sprite 2D so far. Filter nodes. That's our Sprite 2D. Which you have should now when you have a Sprite 2D node. Sprite 2D node needs a texture display and hit turn right. Empty. Godot. Can't spell. Excuse me. Oh. Every 3D straps extends right to D. Oh my god, I'm about to code. Should probably check my stream. Oh jeez, got a message. Sorry dude. I will try zooming in. Would that actually help? Can I zoom in like that? Can't zoom in on the whole editor. Sorry, I didn't realise my browser was so small on the stream. What does it look like? Oh Jesus, yeah, that's pretty unreadable. I will try to optimize these streams if there is more interest. Where was I? In this case, it's Sprite 2D, meaning last with the you omit the extensively with your class implicit extend ref counting. Oh, jeez. Okay, so this is like the lowest level class, maybe? Inherited properties include the ones you see in Inspector Doc, like our node texture. By default, inspectors display node. Just in case, fine. Hello world. Okay, let's do this. Fun. Init. Print. Hello world. Yep. Okay. Save the scene. Press Command R to run it. Hello world. I did it. Okay. Does that work? Nice. Okay. GD scripts. Okay, let's add some variables for some reason. Okay, speed equals 400. Bar. My maths is shit, so I actually don't know what's going on here. Equals pi. Okay. Member variable sitting at the top. Every node instances will have its own copy of speed. Okay, yeah, fine. Angles in node work in radians by default, but if you have built-in functions, properties table, and you prefer to calculate angles in degrees instead. Okay. We can use the progress function with a node class if you prefer to define a class with node. Like Sprite 2D Godot can call the function every frame past an argument delta. Time elapsed since the last one. Okay. Games work by rendering many images per second. Each quarter frame, they do it in a loop. Okay. We measure the rate at which a game produces images in frames per second. Most games aim for 60 FPS, but you might find figures like FPS, like 30 FPS slow on mobile devices, or 90 to 240 for virtual reality games. The game engine do their best to predict the world and render images. Yeah. Okay, this is how any motion works. I got it. Okay, at the bottom define the function process delta. Okay, so this is an existing kind of method that exists, and this gives me a way to tap into the game loop. This from understanding rotation, increments, angular speed times the delta. Oh, Jesus. Delta. What's wrong with this? Go those virtual functions that say built-in functions you can override to communicate with the game engine to start with. Okay, yeah, these are functions that I'm overriding. Got it. The line inside the function increments a sprite's rotation every frame. Its property inherited from Node 3D extends it, controls rotation. So if I run this, it already works. Run this thing. What is happening? It's not working. Why is this not working? So the icon's not even showing now. It was definitely showing before. If I comment all this out, does it appear again? I'll just push that out of the way. There it is. Okay. Let's take it over here then. It's over here. Okay. So it comes this way. Run the scene. Okay, the thing I don't understand is how. Oh, is it because I've attached this script to it? Right, okay, so rotation is a property that's inherited from Node 2D, which Sprite 2D also extends. Okay, because this seemed a bit magical for some reason. How did I know, like, what is actually available? Is there, like, a way to see? I guess you need to consult the Sprite 2D docs. The properties, centered, flip, frame change. If I go to this, I'm guessing I can see like rotation. Global rotation. There it is. So rotation's there. So was that in Sprite 2D as well? No, it wasn't. So you kind of have to go up the tree sometimes to figure these things out. Fine. Okay. Okay, fine. Position or process. Yeah, okay. So, okay. So we can have velocity, and then we can change the position like that, and that will make it spin around like crazy. Is that right? It's going the wrong way. What did I do wrong? Velocity, vector up, rotated, rotation. Was that supposed to go? Is that supposed to go in there? No. Oh my god. Crashed it. We define a local variable named velocity, a 2D vector representing both direction and the speed to make the node move forward. We start from the vector 2 class's constant vector up. A vector pointing up and rotated by calling vector 2. Method rotated. This is vector up rotated. It is a vector pointing forward relative multiplied by speed. It gives us velocity. Okay, move the node forward. We get velocity times delta to the node's position to move it. Oh my god, I forget game dev has so much maths in. What is a vector 2? Okay, it's just an array of numbers. Okay, so that is like the coordinates. Okay. Okay. Why is this crashed? That kind of concerns me a little bit, that Godot is crashing on a very simple game like this, if you can even call it this. Okay, so let's run this again. How do you run the game? So, why does that just go up like that? let's just reread this again. Adding 2 lines inside the function, ensuring the new lines are indented the same way before them. Okay, alright, so this is what it wanted me to do. What? What's going on? Barn velocity. There we go. Copy and paste. I'm actually struggling with maths a little bit here. This is embarrassing. So this makes it spin around 360 degrees. And we're here saying take the rotation with the speed and update the position of this using the delta. So if I was to print the delta, what would that give me? Right, anyways, that. Things have been around. Maths. Maths is hard. Let's go next. Listening to a player's input. Cool. Now this is where it gets interesting. Let's look at another important feature in this gameplay controls. Sprite 2D code. You have 2 main tools to process the player's input and Godot. On-handle input process. It's built in virtual function. It's a tool you want to use to react to player events, like pressing space to jump. Okay. The input singleton, a singleton is a globally accessible object. Godot provides several access. Okay. For turning, we should use a new variable direction in our process function that replaces that. Okay. Place the order line. Wait. We're getting rid of everything? What's the input? Okay. this makes sense. Okay, so you press left, X, I'm guessing X is -1, and the other direction is 1, so we can move left and right. So increment the direction by 1 pixel. Okay, so why do we still need rotation? So our direction is a multiplier representing the direction in which the player wants to turn. Oh, I see. Right, so that is rotating the player left and right. Thank you. A value of 1 means the player wants to turn right, and -1 wants the player to turn right. Okay. Finally use direction as multiplier. Okay. Rotation plus equals angular speed. Direction minus delta. This will ignore code that moves the icon's position in a circle without using input from previous exercise. So what happens here? Oh yeah, nice. Oh wait, so this is supposed to be right. Okay. That was fun. To only move when pressing a key, we need to modify the code that calculates the velocity. Uncomment the code and replace the line var velocity. Okay. So we are setting a velocity variable. Rotate it. Take the rotation. So let's be like that, right? Take the value of the rotation. Speed is 400. Okay, so it's moving forward. So that should work. Because we need to update the position. Which is that. Okay. So we don't need this anymore. There we go. I am a game dev. I am game dev now. I made a game. So there is a game. Da-da-da-da. Okay, so tank game. Fun. Fun, fun, fun. Anybody in chat to experience me building my first game? Alright, it's a silent one. So I want to read up about a little bit is this Vector 2. So I understand that this is an array, but it looks like there's a bunch of helpers that come with it. So I want to see the up. Okay, so there's a whole bunch of constants that I can update here. So we start at a 0. We can increment it by 1. So it's just updating coordinates basically. Vector 2 coordinates. Okay, cool. So Vector 2 can actually help model. So I don't actually have to make it move like a tank. So if I did this, right, okay, cool. Oh, Jesus. Yeah, so how'd you do 2 button presses? Interesting. Can you do like and? And? Yeah, that doesn't work the way I think it does. I will have to revisit that. Signals. Should I leave signals another time? This is kind of a long video already. I think I am going to leave signals for tomorrow. Thank you for tuning in.